Mining of mineral resources normally requires removal of large volumes of soil and rock before the depth of resources is reached, and historically, very large areas of the landscape have been excavated to reach relatively small areas of mineral deposit. The deeper the deposit, the further beyond the edges of the deposit, the higher layer of soil and rock must be excavated to reach the deposit, often causing widespread damage to the local environment. It's heartbreaking to see such destruction of pristine environments. JETMINE has come up with a solution to this problem, offering an environmentally sustainable mining technique which uses brand new technology never before used. As we can see here, all the mining equipment needed will fit onto 5 trucks, including wash plant and water filtration equipment. This equipment allows us to be mobile and minimizes the footprint on the ground to save the environment. Once the drilling commences, as we can see on the animation, the high-pressure water supply is directed to the cutting nozzle from multiple high-pressure pumps that are allocated in separate truck. Additionally, 2 hydraulic fluid supply pipes is pressurizing the cylinders to stabilize the cutting pipe and operate the core drill rotating process. Also, electrical cables added to operate the cutting nozzle. Separately, abrasive feed is added to the rotating jets on the end of the cutting nozzle. This essential addition is important if the cutting required to penetrate through the stone. Extracted material begin to flow out through the large suction pipe in the middle and entering to the processing equipment. From the processing equipment, the tailings are directed into underground void of the previously mined location. In early stages of the drilling, until we're reaching the desired mining layer, material are just processed through the water separation equipment before returning to the ground. Only during the mining process the material are directed through the mineral separation unit. The external core drill begins to rotate and progress underground. At the same time, the internally allocated nozzle with suction pipe is cutting the ground and removing the loose material. Multiple rotating jets are allocated at the cutting end of the nozzle by slowly rotating. They're slicing and softening the ground to be sucked out through the internal pipe. The purpose of the internally allocated nozzle is to cut and remove the ground ahead of the core drill and make the space for it to progress deeper. Please note that during the drilling process, the internal pipe with the nozzle is in fixed position and only the external core drill is rotating. On the inside wall of the core drill, we're introducing rollers for uninterrupted operation of the internal pipe and multiple lubrication transfer tubes. When the external core drill is reaching deeper underground, the lubrication process is playing an important part to reduce friction between the ground and the drill. Lubrication transfer tubes are running along the whole length of the core drill, with equally spaced outlets through the core body for efficient lubrication. Now we're reaching the depth at which we intend to mine. Bendable sections of the mining device work together with cutting nozzle to create a bend in the pipe. This action allows extraction of the material in larger volumes. First stage of mining is to prepare the ground for enlargement process. This stage involves removing the first ground layer of the desired mine location and replace it with concrete that acts as a preventative measure for strengthening the future sealing of the mining void. By inserting the rigid poles in the concrete all the way from the top, we're keeping it in the fixed position, which is preventing the slab from collapsing on the mining nozzle during the enlargement process. Enlargement process further underground is taking place directly underneath of the concrete slab. Reinserted extraction pipe with nozzle is cutting a single access hole through the concrete and continually removing the desired deposit. Further progress deeper underground the extraction is not limited by the design of the device. As the mining continues deeper underground, the newly formed cavity will have to be pressurized to help raise the material to the surface. This technology is allowing selectivity of the mining ground. The bendable mining device can rotate to exclude unwanted locations or large boulders. One of the advantages using our technology is that there is no cutting equipment in direct contact with the ground. This means there's less wear on the equipment and less maintenance required. All the mined material that extracted and processed on the trucks are returned to previously mined cavity. Once desired material is extracted, backfilling stage can begin with processed material from next mining location. When cavity is completely filled, then metal rods can be partly removed and used at next location. The key aspect of this invention is that it's now possible to extract relatively large volumes of the required material from a single access point on the ground, which is no more than half a meter wide. This technology will not only save time and money, it will also prove to be the safer option for future mining.